Today we're going to talk about slope and the graphs of lines. When we think of graphs, we think about plotting them using the x and y axis on the coordinate plane. The coordinate plane is broken into 4 pieces called quadrants, quadrant 1, 2, 3, and 4. The point where the x and y axis intersect is known as the origin. We sometimes call the coordinate plane the Cartesian plane in honor of René Descartes, the mathematician you see on the screen in front of you. René Descartes used the coordinate plane to do a great deal of work in geometry. When we talk about graphs, we often talk about the slope. Slope describes the steepness of a line. Slope fits into one of 4 categories. When we look at lines, we always look from left to right. Notice in the first example here in the red box, when we go from left to right, the line goes upward. We say that that has positive slope. The second one, when I look at it from left to right, the line goes downward. We say that has negative slope. Finally, we have a flat horizontal line. That has 0 slope. Remember, slope is given by rise over run. This has no rise. It doesn't go up or down ever. But it does have an infinite amount of run. 0 over any number is 0. And so therefore we say that this line has 0 slope. A vertical line has an infinite amount of rise, but no run. If we look at our fraction, we would have a 0 in the denominator. And we can't have 0 in the denominator of a fraction. That's undefined. So if we have a vertical line, we say that it has undefined slope. I always think of the jackrabbit at Seabreeze. If I'm standing in front of it, it has right here, it's going uphill, positive slope. Now it's going downhill, negative slope. Here it has 0 slope. It's like it's sitting in the station. And the last one, well, I guess it's kind of like it crashes into a wall. When we want to graph a line, we can use a point and the slope. Here we have the graph that's formed by the point 2, -1, which is shown in red, and they want us to use a slope of 3/2. Positive slope means I'll go up and to the right. Up 3, right 2. Up 3, right 2. And I continue that process to plot as many points as I can. I can also continue the pattern going in the other direction. Once I've plotted my points, I can connect them with a ruler and then construct the arrows on the end. Then I can answer a whole lot of questions about it. Does it represent a function? Yes, it passes the vertical line test. Is it 1-to-1? Yes, it passes both the vertical and horizontal line tests. What about the domain and range? The domain is left to right. It goes in both directions infinitely, so we have from -infinity to positive infinity. The range is from bottom to top. Again, it goes down forever and up forever. Our range is from -infinity to positive infinity. The second example is for you to try. They want us to construct a line that goes through the point 3, 2 and has a slope of -1/2. First thing you'll want to do is plot the point 3, 2 and then use the slope. The only difference here is that because the slope is negative, instead of going up and to the right, we will go down and to the right. Please pause the video here and try this example. Let's see how you did. We began by plotting the point 3, 2. Then, because our slope was negative, we went down 1/2, down 1/2, and used that idea to plot a whole bunch of points. Does this graph represent a function? Yes, it does. Is it 1-to-1? Yes, it is 1-to-1. The domain is -infinity to positive infinity, and the range is also -infinity to positive infinity. Don't forget when you construct your graph to be sure you have arrows on both ends. The next thing we can do is calculate the slope of a line. And this is an idea that René Descartes used a great deal of when he wrote his books in geometry. Slope is given by the formula y2 minus y1 over x2 minus x1. Simply put, you take the 2 y values you have from the points and find the difference, and you do the same thing to the x's. We know the x's are on the bottom because they're like picnic table legs. They're holding up the fraction. Also, we know that run is left to right and x's are run. rises up and down, and the y-axis goes up and down. In our example here, we want to find the slope of a line that passes through points 2, 3, and 5, 8. The first thing I do is identify them. I will call one pair x1, y1, and one pair x2, y2. It doesn't matter which pair you call the ones and which pair you call the twos, as long as they're together. Then I write the slope formula. Always begin by writing the formula. Once you've done that, you plug in your numbers. y2 is 8, y1 is 3, 8 minus 3. x2 is 5, x1 is 2, 5 minus 2. Then I simplify my fraction, and I come up with a slope of 5 over 3. In other words, if I look at the line that has these points, I will go up 5 over 3 to get from point to point. We can verify this by looking at a graph. Notice I have the points 2, 3, and 5, 8 plotted on this graph. If I count the slope up and over, indeed I go up 5 and to the right 3. The second example, they'd like you to find the slope of the line that passes through the two given points. Please remember to write the slope formula down, identify your x1, y1, and x2, y2, and then calculate the slope. Then come back here and let's see how you did. First thing I did was label my x1, y1 and x2, y2. I wrote the formula and then plugged into that equation. Negative 5 minus negative 2 becomes negative 5 plus 3. 3 minus negative 1 becomes 3 plus 1, which is 4. The slope of this line would be negative 3/4. Example 5. Here's some different problems they can give you. They have a line that has a couple of points. 2k, we don't know what the number is for the k, and 4, 5. The slope of the line is 2. Now, you can think of this as the machine. In the machine, we dropped in a 4, it spit out a 5. We drop in a 2, we want to know what number that machine will give you. And they gave us some information to find that out. The slope is 2, and so here's some useful information. I label my points x1, y1, x2, y2, and I label the slope. Now I write my slope formula, and I simply plug in everything that I know. I know that the slope m is 2. I know that y2 minus y1 is 5 minus k. x2 minus x1 is 4 minus 2. Now I can clean this up a little bit and then cross multiply. 2 over 1 equals 5 minus k over 2. The 2 in the denominator came from the 4 minus 2. Now I cross multiply. I have 4 equals 5 minus k, and I solve the equation to find out that k equals 1. So the point is 2, 1. Or if I drop a 2 into my machine, it'll give me a 1 as my output. Example 6 is for you to try. They want you to find the value of d, and they gave you the points negative 5, 3, and 3, d. They say the slope of the line is negative 1/2. Notice we've labeled them x1, y1, x2, y2, and m. Please pause the video here, and then let's see how you did. In this problem, I began by writing the formula for slope, and then I did my substitution. I plugged in everything that I had. Then I simplified my denominator, 3 minus negative 5, to give me the 8 down there, and then I cross-multiplied. Don't forget, when you cross-multiply, you have to distribute to the d minus 3. That gave me negative 8 equals 2 times the quantity d minus 3, and then I solved the equation and found out that d equals negative 1. So that point is 3, negative 1. Or if I use this line as my machine, I drop in a 3, it spits out a negative 1. And so this is the idea of working with slope. You now know how to calculate slope using the slope formula. You know how to graph a line using a point and the slope, and you also know how to find missing values when given the slope and another point.